Hey, in this week's Learn Electronics for Beginners video, we'll be talking about 3 categories of materials used in electronics: conductors, semiconductors, and insulators. We'll talk about the differences between them and their properties and uses with some examples of each type. Okay, I'm gonna make this video at lightning speed. Conductors conduct electricity. Semiconductors sometimes conduct electricity, and insulators don't conduct electricity at all. Bam! Done! Easy. Alright, that is kind of the gist of this video, but there is a little more to it than that. So a popular way to look at the differences between conductors, semiconductors, and insulators is with something called band theory for solids. I'm going to give a quick overview of it because it's helpful for understanding how these categories of materials respond to different temperatures. We won't spend too much time on it at this point though, we're just aiming for a quick overview. We'll get more in depth into materials later on, especially semiconductors. Okay, this band theory stuff kind of presents a little different concept than what we were talking about in the last video. In the last video, we were talking about the valence shell of the atom and how that's where the magic of conduction happens. Because Pac-Man wants to peace out and leave when he's lonely. Well, this band theory divides that outer shell into 2 different bands, the valence band and the conduction band. In conductors, like we were looking at in the last video, there's no difference between the bands because the bands overlap. You could call it the valence band or the conduction band. Either is correct. Because they overlap, electrons can be moved into the conduction band to conduct electricity with very little energy. This isn't the case with semiconductors and insulators though. With those, there exists a gap between the bands. In semiconductors, the gap is relatively close, so it can conduct sometimes, hence the name. This is where temperature plays a part as well. With an increase in temperature comes an increase in energy within the atom. So semiconductors become more conductive at higher temperatures and less conductive with lower temperatures. The vast majority of semiconductors commonly used in electronics, however, have been modified with impurities through a process called doping to modify their electrical properties. We'll dive more into that down the road. In insulators, the gap between the bands is much greater, so it takes a much greater amount of energy to get electrons into the conduction band. That's not to say it's impossible. There's no such thing as a perfect insulator. If you apply enough voltage, any insulator can conduct. Think lightning strikes. Pew! Okay guys, this is really just a different way of looking at what we've already talked about in the last video. When Pac-Man's alone, he wants to peace out and leave. As more electrons exist in the outer shell, the less likely he is to leave. Conductors tend to have 1 to 3 electrons in their outer shell. The best conductors have just 1 in their outer shell. Semiconductors, on the other hand, are marked by 4 electrons in their outer shell, and insulators are non-metallic and typically have greater than 4. Some of the most commonly used semiconductor materials are silicon and germanium. Most insulators in common use are chemical compounds, not elements, although any non-metallic element could be considered an insulator. Some examples include glass, ceramic, porcelain, and rubber. Here are some typical uses of these 3 categories of materials. Conductors are, well, wires. I'm not sure I have to say much more than that. Anywhere you want the Pac-Man to go, the conductors get them there. Printed circuit boards, I guess, have traces embedded in them made of conductive materials, typically copper. There's such a thing as mercury switches too that use liquid metal to conduct. Semiconductors are used everywhere as well, although maybe not as obviously. There's probably about 1 trillion of them in your pocket. Phones and computers use semiconductors as switches to process data and compute and do all the cool things they do. Another example is your fancy LED light bulbs that never last nearly as long as they promised on the box. LEDs are made of semiconductor materials, and also fun fact, those LED light bulbs can technically be repaired when they go bad, if you're motivated. Insulators are used almost everywhere that wires are used. The rubber coating that covers all your wires? Yeah, don't want the electricity escaping. So we wrap our wires in insulation. Gotta keep the Pac-Mans in. Alright, smash the like button if you like this video and hit the subscribe button if you want to see more. Tell me some other examples in the comments below of conductors, semiconductors, and insulators if you can think of any others. This is Life Meet Lightning, bringing a little lightning into your life.